Welcome everyone. This is Jonathan speaking in part of the Web Application Architecture project. For this project, we have chosen to produce a procurement system which is open source and customizable for the users. So the system could be downloaded and the source code will be open, and users can actually customize the system to their specific scenario. Customization includes the organization name, the currency that they are currently using, and other details that we'll be seeing on in the code. Thank you for listening. It's always easier for people to understand the system using diagrams. One best diagram for describing a software is the class diagram. It tells us which classes has which attributes and how they are related. For example, for our system, we have drawn a very simple class diagram which could be expanded further. We have the organization. The organization is the entity in which we keep the customizable informations like the name, the logo, the description, their vision and mission, and the goal of the company. Keeping this information in the entity, that is, in the database, will help us customize the system greatly. And we also have other entities which you could pause the video and review for your detailed information. Also, the source code will be available on Git and you could review the source code also. Okay, now I will be showing 3 of the major roles as the system will be role-based. And these roles will have their own landing page, their own functionalities to do, and their own specific privileges. For example, we would have the administrator, which is now logged in as me, that is Jonathan. The administrator module will have user management and basic operations related to system administration, like organization name changing and logo and other informations in relation to system users administration. Additional informations will be used on other roles in regards to the system. For our case, we would have a procurement officer as a separate role and the supplier in which they would submit the bid and they would see their current status in accordance to the bid that they have already submitted. If you could take a look at the procurement officer's page, which is logged in as Lina, one of our teammates, you could see that the address bar is RESTful, in which we could have items and add, since we are in the add page. But note that the list of items added via this page will also be displayed in here. Here the UI is not complete, as we would have a specification for a specific item. In due time, we haven't completed that. One additional thing to note here is that this user will also have reports. We have implemented the reports, and reports will be generated only in the form of Excel sheets. This page is nothing but a table with an Excel button in which the data will be exported to Excel. Further improvements could be adding a chart that will make it very easy for the end user to look at how many requests that they have made, how many requests have been approved, and other informations. So this is what we'll be seeing when we logged in as the supplier. And the supplier will have the following functionalities: look at bids, look at stock items, and look at requests. So if you look closely, we have all open requests that are posted until May 2017. That's not ideal. And another one in 2016, and the status will be showing here. And whenever we're selecting here, those will be loaded here. If you want to have more information about this bid, we could view the bid here, clear the form results, search, or apply for a specific bid. We will also have stock items of the current inventory that the supplier maintains. With this, let's move on to the technology section. Now I'll be detailing the technologies that we have used in envisioning this system. We have used MySQL for DBMS. For ORM, we have used Hibernate. We have also used Spring MVC along with Apache Tiles. We have used Apache Tiles for rendering the so-called master page or the main page skeleton, in which we don't have to reload the page every time we make a request. Speaking of requests, we have made all our requests RESTful, used Angular along with jQuery for consuming the services, and for providing or availing the service, we have used Spring MVC. In addition, CSS, 3, HTML5, and XML are among the technologies that we have used. Now I'll be detailing you on one pass on how we have created one UI along with the service consuming and service providing up to the database persisting. Let's start from the top down and see the main window. This is the major skeleton that is considered to be the master page. The definition of the tiles is located in an XML file inside a folder called tiles. You could see here that the main definition or the base definition is the main window, which is the skeleton for the page. It should contain header, menu, and body along with the footer. These are the names of the different sections in the page. The header is the top navigation bar. The menu is the left navigation bar. The body is the right section of the page in which the content of the page keeps changing. And the footer is the footer of the page. In the body of the page, please note that we also have additional pages rendered here. This guy or this area means that we have a bead page that will be loaded in a body when called, and find it inside webinf views bead.jsp. If you look at views, we will have bead.jsp, and then next time it will be loaded inside the body. But initially we have a body page. If you look here, we have inside views, we have a body page that is loaded and assuming the initial landing page. So this is the skeleton. And for adding an item, we have just the content that needs to be added and only the controller that we need to add. The rest of the scripts are added in the main skeleton as they will be used for major of the pages. If you have noticed here, we have used an ng-app tag. That is what we meant by Angular. So from this point forward, this section contains an Angular app, an Angularized app, and inside it we have another controller that is the item controller. I could show you this class inside the controller.js. We have it inside resources, Angular, and controller. So here you could see that we have an item controller that is defined in add item. So the model attributes are annotated as ng model, serial number ng model. Having this Angular accessing our attributes in the form, it will cast the selected category object of the item. Should have put a semicolon here so it works. The name, the serial number, and the category are among the item objects that we will see later on. And then we have used Ajax with jQuery. We have avoided using the $sign to avoid the confusion with the Angular dollar annotation. And we have used a post method to submit our form, and the data will be the stringified form of the item object that we have already captured. Once we have submitted this will go to our controller class inside the source package edu mum controller and item controller, and we have an add with a gate. This will be the one getting the page, rendering the page, and this will be the one posting the data. See how simple it is? We don't return any data, but we use the service to save the item that is passed to us via JSON in request body. Simple, huh? Now, inside the item service, we have the item DAO. Okay, we will go to the item service that's been injected. I will go to the item service. This is the interface, and the implementation for the item service is located in here. So inside the item service here, you could see inside the implementation we have the save, the update, the find all, find one, and save item specific situations. So this item service, if you have taken notice, will also auto-wire the item DAO, which have the implementation for all the CRUD operations. So if you see the item DAO here, this is just the interface. It doesn't have anything, but look closely that we have a generic DAO that has all the CRUD operations that we have seen earlier. This CRUD DAO is inside the generic DAO. We have a definition here, and the generic DAO is implemented inside generic DAO impl, which is also an abstract class, but it has all the implementations that we need of the Hibernate with the entity manager to persist our data, to remove, to update, and to find all our data. Basically, CRUD operations. Now, if you want to take a note at the domain classes in which this specific object, for our instance, is mapped to the specified class. For example, if you take organization, sure, we could find organization here. We have the organization which have the following validation, column definition, and attribute definition. This is the basic Hibernate syntax, the JPA syntax. And the table name is called organization. If you note at the class diagram closely, we also have a one-to-many relationship from organization extending to org unit. Now, we should have this relationship in here. Yes, we have one-to-many relationship. This is mapped by organization, which will be situated in org unit. We'll see that later. But one organization would have many org units as the diagram suggested. And if you look at org units, we should have organization attribute that is being referred by the organization domain. Now, if you want to see the database that has been persisted because of this structure, see, we have the org unit, which will have the organization ID, and inside the organization we don't have any organization, since this is the one organization unit, since this is the one side of the relationship. So this is general description of our project. If you're really interested in the project, I'm sure you'll find it helpful, as we have worked on it about a week, a group of 3, so multiply by that 3, and we will have the source code in GitHub. Please improve and comment on our Git so that we could learn more from you. Thank you for listening. Thank you.